So good evening, beta ji, everyone. Now in this session, we are going to discuss phase control rectifier problems. Yes. Yeah. Uh, Ram Nivas Bhargav. Good evening, beta. So do you have any beta basic idea of phase control rectifier? Yeah, Bhargav, tell me. Ram Nivas. So here, beta ji. First, I want to tell you, Unacademy is the best e-learning platform, as everyone knows it, beta. And if you require subscription in Unacademy, either 1 year program or 2 year program, okay, so you can use my code. It will give you maximum discount. And if you have any problem related to subscription or your stream, you can contact me on my number. Okay, it is my personal number, whatever written here. Yes. So now, Betaji, we are going to discuss our first example and read the example carefully, beta. Single phase full wave control rectifier as shown in figure operates at firing angle alpha and its load current is constant. Calculate the value of. Okay. Yes. Now I want to tell you the firing angle of beta. The firing angle of SCR beta alpha 1. I want to write SCR alpha 1 T1 tends to alpha 1 is 30 degree and alpha 2 is also 30 degree. Whereas beta firing or triggering angle of alpha 3 is 60 degree after coming into forward blocking mode, and T4 firing angle beta alpha 4 is 120 degree. Okay, in this particular sequence, okay, you have to follow alpha 1 alpha 2 30 degree and alpha 3 60 degree. After coming into forward blocking mode, alpha 4 is 120 degree. It is your T1, this is your T2, it is your T3 and T4. Okay, here you have current some I naught and all the data is given. The value of E is beta 50 volt. Okay, the value of E is 50 volt and load current I naught is constant, and in this situation you have to describe, okay, this thing. Yeah, let's start with a very good evening, Jitendra. Yeah, Ram Nivas. So whoever present beta at this moment, just listen to me carefully. Our I naught current is constant. The value of R is 10 ohm. The value of E is 50 volt. And beta G, alpha triggering angle for SCR T1 and T2 30 degree after coming into forward blocking mode. And T3 is 60 degree and T4 is 120 degree. Yes. So see beta properly what is the most important thing here. We have to calculate beta supply power factor first thing. Okay. So I want to write beta supply power factor is first thing, and second beta load power. Okay, supply power factor and load power. Okay, and also calculate beta G average current of each SCR, average and RMS currents of each SCR. Yeah, let's start beta. This is our problem completed. So here we have to calculate first supply power factor, second average and RMS currents of each SCR. Yes. Yeah, but also see first alpha 1 and alpha 2 are 30 degree and our I naught is constant. So first I want to draw beta I naught constant without any analysis. So our I naught is constant. Okay, in this fashion our I naught is constant. And now Balak, I want to draw, try to understand, pi here and 2 pi Balak, and this is our alpha 1 and alpha 2 which are nothing but 30 degree. So it is beta alpha 1 alpha 2 30 degree and alpha 3 is beta ji, yeah, you can tell me, it is 60 degrees, so 90 and 60 is somewhere here, it is 60 degree, and alpha 4 is 120 degree, so this is beta 120 degree, this one, and again our cycle will repeat. So here beta we have 30 degree in this way. So here I want to see beta, it is our V naught, this is our IS, and I naught is already done, and we can draw some rest waveform here. This is the omega t, in every case omega t. So it is beta our current I naught, which is already given constant, and now we want to draw V naught. Here beta, this angle you know very well, alpha, it is pi, and this one red color is 2 pi. So here beta, this angle is alpha 3, and this angle is beta alpha 4. Okay, here I want to write this overall angle is alpha 4. Okay, so alpha 4 is 120, alpha 1 and alpha 2 are beta 30 degree, both are equal, and alpha 3 is 60 degree. Now first tell me beta, everyone, at which angle we want to trigger or we should trigger beta T1 and T2. Yes, चलिए जितेंद्र आप ही के साथ बेटा कहानी को आगे बढ़ाते हैं. So tell me beta, at what moment or angle we should trigger T1 and T2. Yes, speak up beta. I naught value is not given beta. I naught value is constant. This information is given beta, and load current is constant. Only this information is given. We will see beta, if some data we require, I will tell you. But here, yeah, very nice beta, 30 degree. So we have to trigger beta T1 and T2 30 degree, and we have to keep in mind our I naught is constant. So in first cycle beta, just follow my marker because I don't want to draw here different color. So see beta, T1 is on in this fashion, then beta load is connected and T2 is on. So somewhere here we can write beta, it is A, this is B. Okay. Now, what will be the output voltage beta in this particular situation? When we trigger beta, try to understand, when we trigger T1 and T2 at alpha equal to 30 degree or omega t equal to 30 degree. Now beta, due to T1 and T2 simultaneously on, our V naught, this voltage beta, V naught will be VAB. Okay, so I want to write VS, I will take numerical value sometime later. So listen to me carefully beta here. In the range of alpha to pi beta, T1 and T2 are on naturally without any controversy. Okay, so T1 and T2 are on. If T1 T2 are on, then V naught will be VAB. Hope so it is clear to everyone. Very nice Jiten, very nice beta, it is absolutely correct. So V naught is equal to beta VAB. आगे की कहानी को समझते हैं बालक. So in this period, next triggering angle is 60 degree. Before next beta pi plus 60, that means to me, before that point beta, whatever I marked, your new device cannot conduct. So it is guaranteed that beta, in the range of pi to pi plus alpha is the second case. Okay, it is our first case beta. And see properly, in this particular period beta, our IS is equal to I naught, and obviously it will be positive. Okay, and in this range beta, pi to pi plus alpha, see properly which pair will conduct. Still beta, T1 and T2 will on, because we require continuous current. So inductor will change its own polarity and provide continuous conduction. Now beta, the most important thing here I want to tell you, T3 and T4 both are forward biased but still off. Both are forward biased but still off. This is the thing. Now in this case beta, what will be the V naught is still VAB, and I naught is equal to IS. Both currents are equal. Now balak, what will be the next case? Somebody tell me. It is second case beta. This is third case. Third case is nothing but beta, we are not supposed to write beta alpha. We have to write alpha 1, alpha 2, both are equal, and here beta alpha 3. Now I want to write beta pi plus alpha 3 to pi plus alpha 4. Because beta at omega t equals to alpha 3, that means 180 plus 60, 240 degree. Somewhere here beta, we want to trigger our SCR T3. So once your SCR T3 triggered beta, then pi plus alpha 3 to pi plus alpha 4, please try to understand. our beta T3 is guaranteed on. T3 is guaranteed on and T4 beta ji guaranteed off, because we are not triggering still. So T4 is guaranteed. Yeah, Rohit Kanna. So Rohit Kanna, yes, tell me beta. Reply Pannuda. Yeah, जैसे आप कहें बेटा उसी हिसाब का रिप्लाई आ जाएगा बेटा. तो जहां भी आपको डाउट है रोहित, जस्ट टेल मी बेटा. या क्या पूछना क्या चाह रहे हैं रोहित, टेल मी. सो बेटा T3 is guaranteed on. Deepak, Abhishek, sorry, Jitendra, it is clear beta. Now see here beta, at alpha or omega t equal to alpha 3, we trigger T3, so T3 guaranteed on and T4 guaranteed off. Now if we apply beta this particular sequence here, so T3 beta ji guaranteed on, T4 beta guaranteed off, then which pair will conduct to make your current continuous? Obviously beta T3 and T2, as I told you many times beta, T4 is not triggered, so T3 T4 cannot turn on beta, and T3 T1 cannot turn on at any cost simultaneously beta. So T3 and T2 will turn on due to the changing polarity of inductance. So see here beta, in this particular case our T3 and T2 are on and they will work beta as a freewheeling action. Okay, as a freewheeling action. So in case third balak, when T3 and T2 are on simultaneously, our V0 will be 0. And when simultaneously beta both are on, it means T1 and T4 are off. So supply is disconnected from the converter. In this situation beta, our IS current will be 0. Please mind it beta, here our power will flow from inductor. Okay, inductor power will flow through beta resistance and battery of load. It means beta inductor of load will charge, okay, or operate your RE load of load, okay, or RE of load. Now here beta, in this case, this is the way. So your slope of inductor current, if your current is continuous, you can show like this, will be negative. Very nice beta. And here beta, in this case, your power will flow, in case 1 beta, your power will flow source to load. And in this situation beta, second case, your power will flow load to source. So this is the basic idea about the response of current. So you can write here positive, and here beta you can write di by d naught something will be negative. So all things are mentioned. Now beta see what will happen in the next case. Next case is fourth one, and this is nothing but beta pi plus alpha 42. Pi plus alpha 42 beta 2 pi plus alpha 1. I want to write all range in the single interval, because beta next triggering will come at alpha 1 equal to alpha 2. Before that one, no triggering will appear. So in this particular range beta, guaranteed T3 and T4 on, because beta T3 was already on and now you trigger T4 also, so both are on simultaneously. And you know very well from the circuit here beta, if T3 and T4 are on simultaneously, then if you apply KVL in such fashion, then beta V0 will be Vs. Okay, so here I want to write in this case equation, or in this case beta, our V0 will be Vs, and this time B is positive, A is negative, so it is VBA. And diagonally on, so obviously beta Is will be I0, and in this range our Is will be less than 0. Okay, less than 0. And somewhere here beta, in the case 1, your Is will flow B to A, so positive. Here beta B to A, so Is positive. Here beta like freewheeling action, so Is value is 0. Otherwise this thing. Now tell me beta, all the things are clear? Yeah, Rohit, how we can trigger our SCR? First, this question rise. By triggering angle beta, by triggering angle or pulse, we can trigger. Okay. See, what is the angle of beta alpha 4 and alpha 3? That means SCR T3 and T4. The SCR T3 angle is beta G. This one 60 degree, and T4 angle is beta 120 degree. And firing angle or triggering angle beta always measured with respect to forward blocking mode in the range of beta pi to 2 pi. Rohit, listen to me carefully. In the range of beta pi to 2 pi, your SCR T3 and T4 are forward bias, okay, because this polarity will change. You know very well how. Now beta T3, T4 are forward bias, and we want to trigger our T3 after beta 60 degree of pi. So pi plus 60 is nothing but 240. So after 240, when you just trigger your T3 beta, your T3 will complete pair with T2. And now beta T4, we want to trigger at 120 degree. It means beta 180 plus 120 is 300 degree. So T4 will trigger at 300 degree, and T3 will trigger with 180 plus 60, 240 degree. Okay, this is the way. So when you will trigger beta T4, at the same moment, your inductor will leap path through T2 beta and will provide through T4. Why? Because this potential is higher, so inductor again will charge. And due to this reason beta, your inductor will operate its own current through the T3 and T4. You know very well beta, in the forward blocking mode, once you trigger your actual devices, then current will flow through the actual devices due to a potential barrier. The moment at which beta you will trigger T4, the moment at which you will trigger T4, T4 beta itself will provide natural commutation for T2. So T2 will face natural commutation due to triggering of T4, and T1 will have a natural commutation beta due to triggering of T3. Okay, so these SCR will provide natural commutation by this circuit behavior. Okay, because the supply is AC, that's why. Yeah, thank you beta. Yeah, thank you Balak, thank you beta. Now here I want to tell you more things beta about this. So all the cases we have done. Now beta, listen to me carefully everyone. What will be the output voltage Balak in this range? Okay, let me select some color. So yeah, blue one is okay, that done. So I want to beta take this color. Now listen to me carefully beta. In this range alpha 2 beta, alpha 1 or alpha 2 to pi, our V0 will be Balak VAB. Tell me it is clear beta? VAB. Yeah, Rohit and Jitendra beta, tell me it is clear? VAB. Now beta, somewhere here still beta T1, T2 are on. So now our VAB will reach into -1 beta. Will reach into -1. And after this moment beta, our case third will start. This is case third beta. Pi plus alpha 3 to pi plus alpha 4. See Balak, T3 and T4 are on. T3 and T2 are on beta. Due to this thing, see here, our V0 is 0. Here beta, our V0 is 0. So here beta, yeah, V0 is 0. So in this period beta, our V0 is 0. And now beta, after alpha 4, you know very well beta, our output voltage will be VBA. So in this case beta, our V0 will appear in this fashion. Okay, so this is beta VBA in the range of alpha 4 to 2 pi plus alpha 1 or alpha 2. And once beta this cycle is complete, your nature will repeat something like this. And here beta we have some negative portion in this way. Okay, so this is the V0 waveform. Tell me Balak, this V0 waveform is clear to all of you, or do you have any doubt? Then I can explain again beta. It is a VAB, this is a VBA beta, this portion from pi plus alpha 4 to 2 pi plus alpha 1, and from beta pi plus alpha 3 to pi plus alpha 4 it is 0, and this is the way to draw V0. Yes beta. Behtrin ya Jitendra. Okay, so very nice beta. See, that is somewhat difficult example beta, and somewhat different also, maybe new for you, because in general beta we triggered our SCR at a particular alpha in proper way, but here beta 2 alpha are same and 2 alpha are different kind of. So we have 3 different triggering position. One is beta 30 degree. Yeah, just wait a minute. Yeah, so beta one is 30 degree, second is beta pi, then pi plus alpha 3, then beta pi plus alpha 4, and so on. So due to this triggering beta, you can say beta like non-uniform triggering. Due to this non-uniform triggering beta, your V naught waveform is looking like this. Okay. So in this particular case beta, obviously we have high ripples. Okay, but still we want to know the concept, how we can handle that type of tricky example. So that's why I have taken all those things. So now in exam, if somebody will ask, you must be capable to reply the answer. Okay, so baby beta, Rohit and Jitendra, everyone, it is clear? Yeah, Rohit, definitely beta. Just you text me beta one message or anything on my number. It is my number beta. Rohit, it is my number. So just give me some text. Okay, I will see. Now see beta, here this is the V naught. Now everyone, please try to identify average voltage of load. Okay, it is your job. Now beta, I want to draw IS current, source current. When source current flows, you know very well beta, I told you, when your diagonally SCRs are on simultaneously, Balak, then our IS current will flow. If our devices are on in column wise or in vertical position, okay, then our IS will be 0. For example, here beta, in first case our I naught equal to IS, in second case IS is 0, and in third case IS is equal to I naught. IS waveform will be something like this. Listen to me carefully beta. Here your IS is positive up to this period. Okay, just wait a minute. Yeah, our IS will be positive beta in this period. And see here, your V naught 0, it means column wise on. So our IS will be 0. And now beta, the direction of current change because T3 and T4 are on. So our IS waveform will change. And again, it will be positive due to T3, T1 and T2 on. So this is the waveform of IS. And this magnitude is obviously I naught. This magnitude is I naught. And here our T1 and T2 are on according to analysis, and in this period while T3 and T2 are on, and in the last period this one T3 T4 are on, and somewhere here beginning in the steady state you can say T3 and T4 are on. Now Balak, please tell me everyone, it is clear? So beta, what will be the V naught average? Rohit, you have already calculated, so I want to match answer with you. Now here beta, the V naught average I want to write here. V naught average is nothing but Balak 1 by 2 pi and integration limit beta. What is the limit? Alpha 1 to, or I want to write beta numerical data, so it will be good for us. So what is the alpha 1? Speak up everyone. Alpha 1 is beta 30 degree and it will move up to pi plus alpha 3. It means beta up to 240 degree. You can write all these values in radian also. Okay. And this is function beta VAB. So VAB is nothing but Vm sine omega t and Balak d omega t. Please mind it. Now beta second case, 240 degree to 300 degree, we don't have any output voltage. See, we have calculated beta from this point to that point. It is completed. 30 degree to pi plus alpha 3 is nothing but 240 degree. Now from this point to this red color beta area is 0. We don't require integration of this area. Now we want to start from this point to that point. Next one, VBA. This red color beta, this waveform we require. Okay. What is this function beta VBA? And we'll start from alpha 4 to 2 pi plus alpha 1. So here I want to write the second waveform is nothing but beta VBA, which is nothing but minus, yeah, it is visual now beta. Okay. So I want to write beta here. Just give me a few seconds, so it will be better for us. Yeah, I want to write beta this thing here downward. Okay, so here beta some plus sign here, and integration limit is pi plus alpha 4 means 300 degree to Balak 300 plus 30 degree more. So 360 plus 30 is 390 degree. And this function is beta VBA is equal to minus Vm sine omega t and beta d omega t will give you overall average value. Now beta tell me Jitendra, how much it will come? Are you sure beta your answer is correct? Here beta, see this way, VAB is equal to Vm sin omega t, and beta VB equal to minus Vm sin omega t from the full wave rectifier concept. Okay. Now beta, if you will handle this way, this equation in some way, then your value will be some. Okay, so sure, thank you beta. So Jitendra, according to Jitendra, I am writing beta, it is 89.665 volts. It is 89.665 volt. Now beta, everyone listen to me carefully again. What is the type of load, Balak? Type of load is RL and E. RL and E. Now beta, when I naught is constant, your average current will be, yesterday I told you beta, average current will be V naught average by R. I naught average is equal to beta V naught average minus E by R. What is the V naught average? According to Jitendra, I am writing beta 89.665 minus Balak is how much? 50, the value of battery, and R is 10. Jitendra, tell me how much it, beta, this value? Yeah. Somebody tell me beta, how much this value? 59. Yeah. It will come beta, I think 3.966. Yeah, thank you beta, 3.967 ampere is the Balak I naught average. So keep this value in your mind because we require after some time. Now Balak, I want to ask you, what will be the load power? See beta, load power is always V into I naught average when our I naught is, when beta I naught is constant. Please mind it, when I naught is constant. Now beta, I naught constant, so we can use this formula directly, and V naught average known beta, I naught average known, so you can tell me this load power. Yes, speak up beta. So what will be the load power is 89.665 into Balak 3.9. या आर के बेटा जी मैं समझ नहीं पाया, अगर आप इसको एलेबोरेट करते हैं, जो भी डाउट हो बेटा प्लीज आराम से पूछिए, हम लोग डिस्कस करते हैं. 3.967 okay, or whatever. Now beta multiplication, tell me somebody. So beta into 89.665. So according to me Balak, it will be 355.66 watt. Yeah, very nice beta. Thank you baby beta. Okay, so here beta, this is the thing. Now I want to tell you Balak, what will be the supply power when converter is ideal. See beta, there is no loss in this rectifier. There is no loss in this rectifier beta. If there is no loss, it means whatever supply will deliver power beta will consume by your load. So in this situation, you can write Balak, P naught is equal to PS is 355.66 watt when your converter is ideal. When our beta converter is ideal, no loss in the SCR. No loss in the SCR. Very nice beta, very nice. बेहतरीन, अच्छा खेलते हैं जितेंद्र. So now listen to me carefully beta. What is the power factor? Cos phi is nothing but beta P by S, as I told you many times, and you know also beta very well. So what will be the power factor? Power factor is nothing but beta PS is equal to P naught divided by VS RMS and IS RMS. Try to understand beta. Here VS RMS is known, okay, and this beta PS P naught known. Only our task is IS RMS. The waveform of IS Balak is this one. Can you tell me beta, what will be the IS RMS? Everyone, IS RMS and I naught beta we have already calculated. I naught is 3.967. Okay, so here beta I want to write IS, so it should be clear to all of you, okay, on the same page. Here beta, just give me few seconds more. एंड तब तक बेटा समझते रहा करिए चीजों को, कभी भी लाइफ में वेट नहीं करना है किसी चीज का. ओके, जो आपको ठीक लगे वहां पढ़िए, खुश रहिए, आबाद रहिए, बट एग्जाम को अच्छे से दीजिए. ओके, या नाउ बेटा, what will be the IS RMS? IS RMS is this one beta. root mean square. So this area balak, this area root mean after root mean square beta, and this time period is beta this 2 pi. So this period beta is similar to beta this period. So either you can use that period or this period, whatever, doesn't matter. I want to use beta this period after making a square. It will be beta I naught square into how much this width beta pi, and alpha 3 is 60. So beta pi plus 60 is 240 degree. So beta I want to write in degree only, 240 degree, one term. This area is done beta. Plus we have to also consider that area beta. And this area is nothing but, listen to me carefully beta, alpha 4 is 120. So 60 degree this, 60 degree this. So remaining is also 60 degree. So it is beta 60 degree. So plus I naught square into 60 degree is the total overall area beta after making a square this, divided by 2 pi and 2 power half. Okay, what is the value of I naught? You know very well. And I want to take beta in place of 2 pi, I want to write 360 degree. So somebody tell me beta what will be the value? I naught is outside, and now 240 beta plus 60 is 300. 300 by 360. 300 by 360 is how much beta? Yeah, somebody tell me. Root 5 by 6. Very nice beta. So I naught root 5 by 6, and this value beta will be IS RMS is 3.96 5 by 6 under root answer into 3.967. So 3.62. Okay beta. So this IS RMS I want to write here by different color. IS RMS will be balak 3.621 according to my calculation ampere. Okay, this is the IS RMS. So keep this value in mind beta, 3.621, and put here beta. So what will be the load power is 355.66 divided by beta 230 is RMS voltage, and 3.621 will be, yeah Jiten, can I write beta your answer? It is correct, 0.427. okay, match it beta, it is correct or not, into 230 and 355.66 divided by answer. Yeah, very nice beta, absolutely correct Jiten. Yeah, now tell me balak, it is clear? बालक एक क्वेश्चन ऐसा आ जाए जितेंद्र, क्या लगता है बेटा कर पाएंगे? या व्हाट इज योर फीडबैक जितेंद्र, कितने बच्चे कर पाएंगे बेटा एक क्वेश्चन ऐसा? या वेरी नाइस बेटा, वेरी नाइस बेटा. नाउ सी the beta beauty of this question. In this problem we have triggered our SCR at different values of firing angle. Okay, and due to this region beta, like different values of firing angle, the ripple in the output voltage beta increases. The ripple in the supply current is also increased beta. Why our power factor is somewhat high? Because beta this time your supply is passing DC current. See beta here, your IS waveform, this current beta, the most important point here. I always yeah beta, this point IS here. Now see beta, this positive area is not equal to negative area, is not equal to beta negative area. It means IS average is not equal to 0. So due to beta this DC current which will flow through the supply, your power factor will decrease. Here beta the average output voltage is somewhat disturbed. The ripple are high. Here beta ripple are high. So efficiency will also decrease. So what will be the efficiency beta if we want to calculate? Then it is not easy, because easy means beta calculation will be tough. But if you want to use any formula of efficiency, you can write simply V naught average into I naught average divided by beta V naught RMS into I naught RMS. This thing is cancelled, but V naught average by V naught RMS. V naught RMS is somewhat tricky beta. You require 5 to 6 minutes in the calculation, and by this thing beta you can calculate efficiency. Yeah, tell me beta, everyone, it is clear? Okay, so thanks beta everyone. अच्छा लगा आपके साथ समय बिता के. Here, beta, we have to calculate supply, power factor, and load power. All those things are clear. Now, average and RMS current of each SCR. Average and RMS current of each SCR. See, beta, I want to draw all the waveforms of devices. Listen to me carefully, beta. Here, I want to draw first I naught. Is this one, beta? I naught. And be serious, beta, at this moment, because now example is not tough. टफ चीज तो हम लोग पहले ही डिस्कस कर चुके हैं बालक. And this is our pi and so on. Okay, and here beta I want to take next angle. Let us assume beta it is our alpha 1. Okay, so this is our alpha 1. Okay, and here beta it is our alpha 3. It is our alpha 3, and yeah, this is our beta alpha 4. This is our beta alpha 4. Okay, now everyone tell me beta what will be the value of what will be the waveform of IS. So this is I naught beta. The waveform of IS is something like this. Please match it beta. This one, negative, then positive, up to beta this, and somewhere here it is 0, and then negative in this way, and then positive. Okay, so here beta it is the waveform of IS. It is I naught. Somewhere here balak T1 and T2 are on in this period beta, and in this period beta T3 and T4 are on, and somewhere here beta T3 and T2 are on beta, and here T3 and T4 are on. So somewhere here beta T3 and T4 are on. T3 and T4 are on. Now beta ji, everyone listen to me carefully. What will be the IT1 average? Everyone tell me beta by this thing, IT1 average. Yeah, start it beta. IT1 average. So T1 is on only in this range beta, otherwise IT1 is 0, and again it will trigger in this fashion. So it will flow beta alpha 1 to pi plus alpha 3, and this magnitude is beta 3.967 whatever. Okay, I naught. Yeah, now beta see properly here. So IS is beta 3.967, no 3.621 and 3.967. Wait a minute. This is beta 3.967 ampere. Now beta what will be the IT1? This is IT1. IT1 average beta is nothing but 3.967 into this width beta. How much this width beta? 30 degree here less, and beta this is 60 degree extended. Okay, after 60 degree your alpha is completed. So beta this angle is 240, and 240 minus 30 beta is 210. So 210 degree divided by 360 degree will be the average current of this. How much beta this value will come? Very nice. How much beta this value will come? Yeah. So then beta, you are absolutely correct, and by this way we can handle this thing. So 3.967 into 210 divided by 360. So it will come beta 2.314 ampere. Okay. Now balak tell me, RK, baby, and yeah, Rohit, everyone beta, it is clear? See beta, somewhat you have to understand, because we can't handle all the waveforms of current. But once you know beta in the region in which your particular devices are on, you can easily calculate beta average and RMS values. One I have calculated, rest you can calculate. So tell me balak, it is okay for you? Now beta, it is our next example. Read the example carefully. I want to ask you beta, I want to change this question. The operating firing angle beta is 120 degree. The operating firing angle is beta 120 degree. The load current is constant, and its average value is beta 10 ampere. Okay. this thing. Okay, leave it. The load current is constant. Okay, and I want to change this beta. Only just find out. Only keep in mind beta I naught is constant. Okay. Now beta the power consumed by the battery will be. Okay. Leave this thing. Okay. For you, I want to design somewhat a good question. Okay. See beta, Jiten and baby, everyone, listen to me carefully. It is beta your full wave control rectifier. Okay. The alpha value is 120 degree. And beta ji I naught is constant. Please mind it. Only this information is given. I naught constant. The value of E is beta 500 volt. The value of E is 500 volt. Okay. The value of E is 500 volt. And the value of beta supply voltage is this one. Only this one. And the turn on resistance of each SCR beta is 2 ज़्यादा हो जाएगा beta is 1 ohm. Turn on resistance beta of each SCR is 1 ohm and our I naught is constant. Then tell me beta supply power factor. And here beta I want to make one change also for you, and this change is beta this one. Your E polarity is changed. Downward is positive and upward is negative, and this is your E. Okay, minus plus. And now beta tell me supply power factor. If you have any doubt in the question beta, please ask me. Yes. पावर इलेक्ट्रॉनिक्स है बेटा, जब चाहे जितना चाहे उतना घूम सकता है और हर बात को आपको बारीकी से समझना है. ओके, सी बेटा सिंगल फेज फुल वेव कंट्रोल रेक्टिफायर एज शोन इन फिगर operates at triggering angle of 120 degree. I naught constant. E is beta 500 volt. Turn on resistance of each SCR 1 ohm. The polarity of E you can see here, minus and plus. Top is negative, bottom is positive. Supply power factor you have to tell. So I naught is 33 ampere. Very nice beta. See here beta. First tell me everyone beta, it is electrical motoring mode or like beta generating mode? Yes, everyone beta tell me. It is forward motoring mode or electrical braking mode? It is beta forward motoring mode or beta electrical braking mode. Yeah, tell me. Electrical braking mode. Yeah, very nice. So beta everyone listen to me carefully. It is a regenerative mode, braking mode, and sometimes beta it is also called line commutated inverting mode. Especially beta mind it, line commutated inverting mode. Okay, so the another name of this one is also inverting mode. In this particular case, please mind it beta, resultant power. Listen to me carefully बेटा, अगर आप बैठे हुए हैं तो थोड़ा ध्यान दे सकते हैं, ये आपके लिए काफी अच्छा रहेगा. ओके, कुछ ना कुछ नया सीख के जाएंगे बेटा, इतना वादा है आपसे कि आपके समय का दुरुपयोग नहीं किया जाएगा. ओके, सो ना तो मैं यहाँ पे चिल्लाने जा रहा हूँ, ना जोक सुनाने जा रहा हूँ, बस एक अच्छी बात चल रही है, पढ़ाई है, लेकिन पढ़ाई एडजस्ट करना बेटा सबके बस का नहीं होता है. ओके, तो दिस इज द बेटा वे. The resultant power will flows beta, resultant power will flows load to source. In other words beta, you can say your load will work in a generating action beta and will charge your supply, So it is your single phase supply beta, it is your DC generator kind of, and please mind it beta ji, power will flow in this fashion. And this mode is possible only when beta your back EMF is capable to deliver the power, otherwise not. That's why beta I have in the polarity of battery E. Okay, for new student, if you are not aware with this thing, I want to tell you. Now beta, if your current is continuous and alpha is same for all, it means beta V0 average calculation will be very easy. It is nothing but, please mind it beta, 2Vm by pi cos alpha. What is the value of alpha? Is 120 degree. And beta supply RMS voltage is 220. Okay, Yeah, very nice beta. So here we can write beta 2 into 230 root 2 divided by pi into cos 120 degree. Yeah, tell me beta how much this value will? Yes, everyone, how much this value beta? We not average, I want to ask you. Just formula beta. Just formula, nothing else. Yeah, 230 and I want to write beta 2 into 230 root 2 divided by pi into cos 120. Yeah, it will come beta minus 103.53 volts. But beta, the most important thing I want to tell you here, Jitendra and everyone beta baby, everyone, sabhi log suniye. This V naught average formula is valid when our converter is ideal. Please mind it beta, when our converter is ideal, otherwise not valid. Now, but unfortunately beta, our converter is not ideal. See here beta, the turn on resistance of each device is 1 ohm. Then how much voltage drop beta will occur due to this thing? Can you tell me? Voltage drop beta in average. Yeah. How much we beta? See, the turn on resistance of each SCR is beta 1 ohm. 1 ohm. Then what will be the beta G drop? Because here beta, let us assume this overall is V naught beta. V naught. You know very well beta, V naught will not be equal to Vs. What will be the V naught in this particular situation? Yeah, Jiten, you handle one question beta. Here beta, when our in the range of alpha to pi plus alpha beta, when our T1 and T2 are on, listen to me carefully beta, because this equation will give you answer. When T1 and T2 are on beta, your V naught is nothing but Vm sine omega t properly is correct. But beta minus some drop also, and that drop is nothing but beta 2 into I naught. R and R, two resistance will connect in series beta. This 1 ohm beta and that 1 ohm will have some drop and current will flow in such fashion beta. So your V naught will be this Vs minus this current is I naught and this R that are 1 ohm. So 1, 1 and 2. It means beta here we have to write minus of 2 I naught. Please mind it. So this is the beta V naught average value. Now what will be the V naught function beta? Sorry, this is the V naught function beta, not average value. What will be the average value beta? We can write V naught average is nothing but 1 by pi integration beta alpha to pi plus alpha, and please mind it beta function is Vm sine omega t minus 2 into I naught d omega t. फटाक से बोलो बेटा, it is clear? Yeah, Jiten, it is absolutely correct, beta. You can consider or we can consider, beta. There is no issue. There is no issue. And same thing, beta, I want to prove here. Now, beta, see, leave this thing and handle beta first term. Let us assume only this is present, beta. This is present. 2 I naught is absent, beta. So what will be the formula of 2 V naught average? 2 Vm by pi cos alpha minus beta this value 2 I naught into d omega t means beta omega t. What will be this value? Pi plus alpha beta minus alpha. Listen to me carefully. Integration limit pi plus alpha beta minus alpha and divided by beta this pi also. Divided by this pi also. So it is nothing but beta minus of 2 I naught. Simply. See beta 2 I naught and limit is pi plus alpha minus this divided by pi. So we can write beta 2 Vm by pi into cos alpha minus 2 I naught. Yeah, everyone beta check it whether it is correct or not calculation wise. Mathematical analysis or job is correct or not. Yeah, Jiten, please check it beta. Yes beta. This is the one thing. Now beta, listen to me carefully. As I told you in the beta some starting session of phase control rectifier, these resistance you can also consider in the load. So in that thing beta, what will happen? See properly. Here beta, let us assume your resistance, this resistance beta is not 10 ohm. This resistance is 12 ohm in first case, 12 ohm. So what will be the V naught average beta? V naught average is nothing but E minus this, whatever, some extra 2 ohm also. So that will subtract. This is the way. So beta, in this particular situation, our V naught average will be this one. Now beta, just put all the value here and tell me the correct answer. What will be the answer beta? So I naught average is nothing but, in this particular case, when electrical braking mode beta, I naught average is nothing but V naught average plus beta E divided by R. Be serious. V naught average plus E divided by R. I want to write beta I naught average into R is 10 beta, and this V naught average is nothing but beta 2Vm by pi cos alpha minus I naught, sorry, minus 2I naught, okay, minus 2I naught, and plus E. E is beta how much? 500, I think. So just handle beta this value. I naught or 10 I naught average is equal to beta 2 into 230 root 2 divided by pi beta into alpha is 120 and minus beta 2 I naught and plus E is 500. Okay. So see, all the information is known. Only I naught is remaining. Just tell me beta how much this value. Okay. I will see beta. Jiten, please don't worry. I will change the data. Okay. We will change the data. No issue beta. Yeah, tell me beta I naught average. Everyone, tell me fast. What will be the I naught average? Okay, Jiten, I am writing beta your answer. It will be 33 ampere. No issue beta. Now we know that beta, in this particular case, our IS RMS will be equal to beta I naught average. Okay, because current is constant. That's why beta. And yeah, we will discuss. So IS RMS beta is equal to I naught average. One job is done. Now beta, tell me what will be the battery power. Battery power beta, PE, everyone. See beta, the battery power is here beta, how much? Battery value is beta 500 volt. So here beta 500 into current is 33. So beta, we can write E into I naught average is nothing but beta 500 into 33. How much is beta? We can calculate. Now somebody tell me beta PR, resistive power loss, and this is nothing but beta I naught RMS square into Balak 12 ohm at a moment, 12 ohm. Okay, so this is a beta, or wait a minute. Just give me a few seconds beta. Yeah, this I naught RMS square into beta 12 ohm at a moment. Yeah, how much this beta? Total 16.6. Okay, very nice. Which one? 500 beta into 33. Yeah, so it is beta 16.5 kilowatt. Now beta, tell me only resistive loss beta in load. So 33 square into 10. 33 square into 10 is done beta. It is 10.89 kilowatt. Okay, 33 and 10. Now beta, everyone tell me the switching loss in the converter. Switching loss in the converter beta, due to 1 ohm resistance. Everyone tell me beta, due to 1 ohm resistance. Yeah, it is nothing but beta, try to understand. IT1 RMS. What will be the IT1 RMS beta? In a half cycle it will flow. So is nothing but beta I naught square into pi by 2, pi to power half. So I naught by root 2. Please mind it. I naught by root 2 is the RMS value of each switch. So what will be the power loss in the beta? This SCR-T1 is nothing but beta 33 by root 2 Balak, 33 by root 2 whole square into beta how much? 1. Yeah. So yes beta, very nice. So 33 by root 2 and square beta, and very nice, into 4. So beta this total power beta will come 544.5. Okay, watt. Yeah, just check it beta, this one. Baby beta, everyone, this is the loss in the beta one switch SCR T1. So overall loss beta in the switches will be overall loss. So all switches loss beta is 4 times of previous value, 544.5. Okay, into 4, and it is nothing but beta 2.178 kilowatt. Yeah, tell me Jiten, it is clear beta? Very nice beta, it is clear beta. 2.178 kilowatt in all like overall converter. So see beta, the battery E will work as a source in our case. Battery E will work as a source beta, as a source. Please mind it beta. The battery power PE minus resistive loss beta minus switching loss minus inductor average power should be equal to beta supply power. And this inductor average power always 0. What is the power of battery beta? See here, 16.5 and it is beta 10.8. So I want to write beta here 16.5 minus beta 10.89 minus beta 2.178 is equal to beta PS. So here PS will be, yes, very nice beta. So 2178 and 16.5 minus beta 10.89 minus 2.178. So it will be beta, I think 3.432. 3.432 watt. Yeah, match beta, it is correct or not? Yes beta, match it, it is correct or not? Yeah, no issue beta. So this power 16.5 minus beta, this is 11 around and 11 to 13, so 3 point, yeah, it is almost correct beta. This is the supply power. Yeah, Jitendra, where are you balak? It is the supply power beta. So what will be the power factor? Cos phi is nothing but beta supply power PS by beta VS RMS, that means S into balak IS RMS. Job is done. Now beta, what is this PS? Listen to me carefully. We have calculated 3432 divided by beta VS RMS 230 into IS RMS is 33, I think. Yeah, 33. So 33 beta. Now tell me what will be this answer beta, final answer. 3432 divided by 230 divided by beta 33. Yeah, it is almost beta 0. So it is beta almost 0 means yeah, 230 and wait a minute beta, 3432 divided by 230 done divided by beta 33. Yeah, wait a minute, 3432 done divided by 230 divided by 33. Yeah, it is coming with a 0.4522 is our final power factor. Yes. Yes, beta. Now, Jiten, so I think beta power will not come, whatever you are telling, negative or positive, whatever. So our final answer beta will be 0.4522. Okay. So this is the correct answer beta. And if there is no calculation mistake, then 200% beta our answer is correct. Okay. Yeah. Now tell me beta, everyone, it is clear whatever we have discussed beta here. Okay. Now beta, here I want to tell you in you know very well beta, Unacademy is the best e-learning platform. So if you want to take subscription of beta, either 1 year program or 2 year program beta, 2 years program, you can use my code. It will give you maximum discount beta. Okay, maximum discount. And if you have any problem beta, you can call me on my number. It is my number. Okay, this is my number. Please mind it beta. So the most important thing again, I want to tell you, beta, I want to start one rank improvement batch. Okay, rank improvement batch of circuit theory, beta. Rank improvement batch of circuit theory by 17th of June. So if you are serious, you can attend my that session. Okay, and that is not available beta free. You for that you have some subscription. So according to that you can work. Okay, and if you have any problem, you just call to me on this number. Okay, yeah, thank you, beta. Okay. Okay, thank you, Balak, everyone. We will meet tomorrow at the same timing, beta.